Okay, let's get started. Number one, find the radius of convergence of the following power series. For the radius of convergence, here's the formula. My suggestion is writing it down here. Even if you make a mistake in your calculation, you can get some partial credit. All right. Check this formula carefully. What is an? What is an plus 1? By definition, when you are trying to find the radius of convergence, an is just the coefficient of x minus 1 to the power of n. So that means an, in this case, is just 1 over n squared. It's just 1 over n squared. Be careful, n squared is in the denominator, okay? So it's 1 over n squared. You should not include x minus 1 to the power of n in this an when you are trying to find the radius of a convergence. All right, this is one thing. Of course, n plus 1 will be this. And the other thing is the formula, be careful. The numerator is an, denominator is an plus 1. Okay, later you will see the ratio test. That's in the formula for the ratio test, and it's the opposite. All right, now you take a limit of the quotient and simplify this expression, and you should get this one. It's just a very simple basic algebra, okay? And then you take the limit of this, you get AC that's equal to 1. So the radius of convergence is equal to 1. Similarly, for the second question, for B, an is just a coefficient of x plus 1 to the power of n. So an is just 1 over negative 3 to the n times the root n. An plus 1 is this. Okay, now you use the formula again. Take the quotient and take the absolute value. That's why you don't see the negative sign here anymore, because I took the absolute value of it. Now simplify it, becomes this, and then you see 3 to n, 3 to the n, they cancel. Okay, so, and then you take a limit. The limit of this quotient is equal to 1. So multiply by 3, you get 3. Number 2, show the following sequences are convergent with appropriate methods. So we have 2 questions. You have to use, actually 3 questions. You have to use 3 different methods. For the first one, pinching method. Anytime you see cosine, sine, it's probably required to use the pinching method. Okay, so in this case, the general term of this sequence is greater or equal to 0. It is because sine n is greater or equal to negative 1. So sine n plus root n is definitely positive. Divide by a positive number, so it has to be greater or equal to 0. And on the other hand, sine n is less than or equal to 1. So an is no more than 1. Just replace the sine n with 1. 1 plus root n divided by n plus 1. So an is pinched by these 2 sequences. For this one, you can take a limit of this one and see that this is equal to 0. So the limit of this sequence is 0, and this is already 0, so the limit of an has to be 0. Pinching theorem. Okay, be careful, we are dealing with sequence here. We're not talking about the sum of an, okay? do not write the sigma notation in this question. Any sigma notation in this question will make you lose point. For the second one, you see that this is n over 2 to the n. So instead of finding the limit of Bn, now we can try to find the limit of this function when x is approaching infinity. So basically, here the main difference is n only takes an integer value. X can take any real value. Okay, so this is a continuous function of x. And now we're trying to take a limit. To find the limit of the quotient when both the numerator and denominator are going to infinity, we can use L'Hopital's rule. So the limit of n over 2 to n is the same as the limit of x to the divided by 2 to the x when x is approaching infinity. Now to find the limit, you take the derivative of both the numerator and the denominator. Okay, be careful, we're not using quotient rule to take the derivative of the quotient. Okay, we're taking the derivative of the numerator and the derivative of the denominator respectively. And this is called the L'Hopital's rule. Now, the derivative of the numerator is 1. Derivative of the denominator is 2 to the x times log of 2. In case you don't remember the derivative of a to the x, well, a is a constant. I will write it here. It is equal to a to the x times log a. So derivative of 2 to the x is 2 to the x times log of 2. Be careful, this is not a power function. It is not x to the power of something. Okay, it's a to the power of x. Now the denominator goes to infinity, so the quotient goes to 0. And that means that the limit of n over 2 to the n is equal to 0.